Hello. In this video, we are going to look at the Black-Scholes model to calculate the premium of an option. Okay. We are going to look at just the formula and how we are going to use the formula to calculate the premium of the options. We are not going to look at how we are going to derive the formula of this model. So, to start with, this model has certain assumptions over which the model has been built. The assumptions are the stock does not pay any dividends during the time of expiry. For example, if the time to expiry is 3 months, in this 3 months the stock or the underlying asset will not pay any dividends. The second assumption is that the option can be exercised only upon expiration, which effectively means that it holds good only for European options. Then the market direction cannot be predicted, which means the market is going to move in a random fashion and the movement cannot be predicted, and there are going to be no transaction cost on either buying or selling of an option. And during the time of expiry, the interest rate and the volatility will remain constant. The interest rate and the volatility is going to remain constant over the time of expiry. Finally, the stock returns are normally distributed. So these are the assumptions on which this model has been built. Now we look at the formula to calculate the option premiums. To calculate the call option premium, we are assuming the call option premium to be C. To calculate C, what you're going to do is we are going to take S into n of D1 minus X into e to the power of minus RT into n of D2. Here S stands for the stock price or the asset price. N of D1 is nothing but the normal distribution value of D1. X stands for the strike price, R for the risk-free interest rate, T for the time to maturity in years, and n of D2 is nothing but the normal distribution value of this D2. To calculate D1 and D2, we have separate formulas over here. Okay, to calculate D1, you're going to, how do you calculate this? Ln of S divided by X plus R plus sigma square divided by 2 into time to expiry divided by sigma into square root of T. To calculate D2, D2 will be calculated D21 minus sigma into root of the time to expiry. So these are the formulas for you to calculate D1 and D2. Once you have calculated D1 and D2, you can substitute them here in this formula to calculate the price of a call option. Similarly, to calculate the price of a put option, you have to use this formula where it is X into e to the power of minus RT into n of minus D2 minus S into n of minus D1. Alright, so these are the formulas for you to calculate the premium of a call option and the premium of a put option. Now we are going to look at a sample problem for which you are going to calculate the call option premium and the put option premium. The given information are these: the strike price is 200, the asset price is 180, the volatility is 20%, and the time to expiry is 3 months. Please understand, it is given in time to expiry is given in terms of months. You have to convert this in terms of years to in our formula. And finally, the risk-free interest rate is 6%. Now we are going to substitute these values into our formulas to calculate the premium values. Okay, first we are going to calculate the value of D1. So the value of D1 is minus 0.8536. Okay, and now we are going to use that value to calculate our D2 value, and the D2 value is minus 0.9536. Now that we have the values for D1 and D2, we are going to find the normal distribution values for D1 and D2. So this is n of D1. So how you find this value is you are going to use a table which is a normal distribution table. And if you look at this table, on the left side are the Z values which are effectively the D1 and D2 values. For example, for this, how do you interpret this is minus 3 point, this value is your Z value. No, sorry, this value is your normal distribution value, and for Z value of 3.90, this is the value. Alright, and this is the value for minus 3.91, and here this value is minus 3.92. Okay, this is how we are going to interpret values from the tables. So for us, we have 4 decimals, which is 0.8536, whereas in our table we have provision for only 2 decimals at the max. So we are going to take the first 2 decimals from our d value, which is 0.85. Okay, so I go back to the table, I go to the value of 0. So here you have minus 0.8, so ours is 0.85. So this value is 0.80, this is 0.81, 0.82, 0.83 and 0.84, and this value is what we have for 0.85. So I take this value and substitute it here, 0.1976, 0.1976, that is a value for n of minus d1. Similarly, I'm going to find value of n of d2. My d2 value is minus 0.9536. So since the table has only 2 decimals, I'm going to consider the first 2 things, which is 0.95. So I go back, so 0 minus 0.9 is here, and 0.09091929394, and this value is 0.95. so I take this value and substitute it here. So now I have values for n of d1 and n of d2. So the next thing that I'm going to do is calculate the call option premium. Okay, so before calculating the call option premium, I'm also trying to find the value of n of minus d1 and n of minus d2. Since the values of d1 and d2 are already in negative, if you look at this, this is where we have calculated d1 and d2. We have negative values for d1 and d2. So in this formula, when we calculate n of minus d1, so minus of minus would become plus. So effectively the value that you're going to do look here is n of is just 0.8536. So I go back to the table. Here I have the values. So since we have only 2 decimals in this table, I'm going to look at the value for 0.85. I have 0.8 here, 0.80, 81, 82, 83, 84 and 85. Okay, so this is a value that I need. So I'm going to take that value and substitute it here. Similarly, n of minus d2, minus of minus, it would become plus. So I have to find the value for n of 0.95. I go back to the table, 0.9 is here and 0.5 is here. So n of 9.5 is, n of 0.95 is 82894. This is a value for n of d minus 2. So I have put that value here. Now I have all the values that I need. I'm simply going to substitute them and find the call option premium and the put option premium. So effectively in our calculation, the call option premium is 1.876 and the put option premium is 18.899. So this is how you use Black-Scholes formula to calculate the call option premium and the put option premium. I have one more sample problem for you to calculate and practice. So these are the information that have been given to you. Now similar to how the first problem was solved, you can substitute these values and find d1, d2. Then using d1 and d2, you can find n of d1, n of d2, and then n of minus d1 and n of minus d2. Substitute those values into the formula and calculate the call option premium and the put option premium. So if you do that, these are the solutions that you will get. You can check if you get the same values that you get here, that's given here. Thank you.